2.8, function operations and composition. Basically what that means is we're going to add and subtract and multiply and divide functions together. Composition means we're going to plug a function into a function. Example 1 says there's an f of x and a g of x, so find the following. I think the first thing you need to understand is the notation. When they say f plus g, that just means they're adding the functions. Of 0, I think it would probably be easier if you think of it like this. F of 0 plus g of 0. That means the same thing. Okay, that means the same thing. I think you're probably going to understand that a little bit better. So look at it that way. Plug in the 0 into the f function. So you're going to have 3 times 0 minus 4. Feel free to do some of that in your head if you want to. That's going to be 0 minus 4 is negative 4. Likewise, we're going to plug in 0 into the g function, and that would be 2 times 0 squared minus 1. That's going to be 0 minus 1 is negative 1. But we're adding those two things together. So it's negative 4 plus negative 1. The answer is going to be negative 5. If you want to show a little bit less work than that, be my guest. The next one's going to be f of 4 minus g of 4. So if you can do that in your head and see that's going to be 12 minus 4 is 8, then go for it. Okay? But we're doing 3 times 4, so plug in the 4. That's 12 minus 4 is 8. And then g of 4 is a little bit harder to do. Use a calculator if you want to. It's 2 times 4 squared minus 1. That's 2 times 16 minus 1, or 32 minus 1 is 31. And this is a subtraction problem, so we're going to do 8 minus 31 is negative 23. Next thing, guess what? We're going to multiply. And they want me to do f of negative 2 times g of negative 2. So I might need to see the function. F of negative 2, so plug in negative 2. Three times negative 2 minus 4. That's negative 6 minus 4 is negative 10. And g of 2, 2 times negative 2 squared minus 1. Be careful with your negative. When you square that negative 2, that's going to be 4. So 2 times 4, that's 8 minus 1 is 7. So keep in mind we are multiplying. We have 10, or negative 10 times 7, negative 70. Next problem, division. So we want f of 3 over g of 3. F of 3, that's going to be, plug in 3. You can see that's 9 minus 4 is 5. On the bottom, g of 3, 2 times 3 squared minus 1. That's 2 times 9 minus 1, or 18 minus 1 is 17. So we get this fraction 5/17. Okay? Domain. To find the domain of a function, you must look for problematic, quote-unquote, x values. All right? Look for problems. Problems arise when an x value produces 0 on the bottom of a fraction or a negative inside of a square root. You've seen that before. Okay? But you kind of have to look hard sometimes for those problems. If there are no problems, then the domain is all real numbers. So example 2, let f of x equals 3x plus 1 and g of x equal 2x minus 8. We're going to do the same thing, I guess, but this time we have variables. So that first problem says to multiply. You're going to multiply f of x times g of x, or 3x plus 1 times 2x minus 8. So we're multiplying. Some of you might call that a FOIL. Some of you might call it distributive property. Distribute, you're going to have 6x squared minus 24x plus 2x minus 8. Combine your like terms. That's 6x squared minus 22x minus 8. There's the product. Okay, that's the answer. But it also says to find the domain. Okay, and that's tricky. Most of the time, or a lot of the times, it's going to be all real numbers. But to find the domain, you have to look for problems. Problems arise when you get a 0 on the bottom of a fraction or a negative inside of a square root. So when we look at this answer, when we look at this problem, I don't see that happening. There's no fractions, so you can't possibly have a 0 on the bottom of a fraction. There's no square roots, so you can't possibly have a negative inside of a square root. There are no problems, therefore the domain is all real numbers. And what that means is, when you think about domain being the x numbers, what that means is I'm allowed to plug in anything I want. I can plug in any x number into that problem that I want, and it'll be fine without any issues. So then we look at this one. We're dividing, so I'm going to skip a step and just go straight to it. We're dividing f of x over g of x. Okay. And if I could reduce that fraction, I would, but I don't really see anything to reduce. So really, that's it. That's the answer. Okay. That's the quotient of dividing. Now the domain, though, is not going to be all real numbers this time. Since we have a fraction, and especially since we have a variable on the bottom of a fraction, we have a situation where the denominator could potentially equal 0. We don't want the denominator to equal 0 because that's going to be a problem. Okay? So we're looking for where there's a problem, and we're saying we don't want that. We want other stuff. Okay? Well, we'll take everything else except for that problem. So if you think about it, 2x minus 8 is not allowed to equal 0. So just solve that equation. If I add 8 over, 2x is not allowed to equal 8. And if I divide by 2, x is not allowed to equal 4. Because if x equaled 4, we'd have 0 on the bottom of a fraction. Okay, that's going to be bad news, right? So the domain is going to be everything else besides 4. So in algebra class, you might have said something like all real numbers, x does not equal 4. That's right. But in interval notation, it helps to think about a number line. Okay, if this was 4 and we wanted all real numbers except for 4, think about that in interval notation. There's two pieces. There's a piece on the left that says from negative infinity to 4, but not including. And there's a piece on the right that says from 4 to positive infinity. Put a little u for union in the middle there, and that's how you're going to write it in interval notation. Okay? Here we go. Number 3, f plus g of x. We're just adding the two functions. So f of x is 2x plus g of x is square root of x minus 5. Now, if we could simplify or do something with that, we would, but we can't really simplify. So we can just leave that as is right there. There aren't any like terms that we can combine. That is the sum. But the domain is the hard part here, okay? We look for potential problems. And I don't see any fractions, so I can't have a 0 on the bottom of a fraction. That's not an issue. But I do have a square root, okay? I have a square root. And so I have this issue of this thing being negative. Let me change that color. This thing right here could potentially be negative, and I don't want it to be negative, okay? So that thing right there must be greater than or equal 0. X minus 5 must be greater than or equal 0, for if it wasn't, I'd have a negative under the square root. That's going to be a problem. That's going to be a non-real answer. So add the 5 over. X must be greater than or equal 5. If you plugged in any number, try it. If you plugged in 4, you're going to get a square root of a negative number. If you plugged in anything that's less than 5, you're going to get a square root of a negative number. Okay, so that's not allowed. So I think for domain, a lot of the times it's easiest to look at it on a number line. If you had a 5 right here, and if you graphed that, just think about what that number line says. That number line is showing me exactly what the interval would say. Okay, the domain, just look at the number line, is going from 5 to infinity. That's your domain. Part B, we're dividing. G of x is the square root of x minus 5 over f of x is 2x. There's nothing to simplify here, so I would just leave it alone. That's my quotient. But for domain, the domain is the hard part. I have to look for the problems, okay? I have 2 problems that could arise. Could I get a 0 on the bottom, possibly? Yeah, okay, so we have to look at that. So 2x cannot equal 0, or in other words, divide by 2, x cannot equal 0. If x was 0, we'd have 0 on the bottom of a fraction. That's going to be no good, okay? But then you look at the top, you could potentially have a square root of a negative number. So x minus 5 must be greater than or equal 0. Or x must be greater than or equal 5. Once we add that over. So if you look at a number line, okay, x is greater than or equal 5. That's just what we just did a second ago. Looks like that, right? And we don't really have to worry about the 0 because we already know that x has to be greater than or equal 5. So we don't even care about any of this stuff. Any of that stuff. None of that stuff can work, especially not 0. 0 can't work because it's on the bottom, but nothing can work that's less than 5. So the domain is just x is greater than or equal 5. Same as the last problem, from 5 to infinity. Okay, number 4. Students really struggle with this one. It's not supposed to be hard, but students really struggle with it. If you think about what this is telling me to do, it says f of 3 plus g of 3. You're going to have to get those values from the graph, okay? F of 3 means go to x equals 3 on the graph. So if I go on the graph, x equals 3, 1, 2, 3 is right there. F of 3 coincides with this point right here, which coincides with this y value, or negative 1, 2, 3, 4, 5, 6. That looks like negative 6 right down there. F of 3 is negative 6. G of 3, you go on the graph right here to this point, and that coincides with this y value over here. That's 1, 2, 3. That's 3. G of 3 equals 3. And so all they're saying to do is add those two numbers. Negative 6 plus 3 is negative 3. That's what you get. Okay, kind of weird, kind of tricky for some people. Now let's do the other one. We've got g of 0 minus f of 0. So look at g of 0. G of 0 is right here at 4. F of 0, oh wait, did I do that backwards? I did that backwards, didn't I? G is the red one, isn't it? G is the red curve, or the red graph. Okay? So I did that backwards. G of 0 is right there as 0. F of 0 is this number 4. So all I'm doing is 0 minus 4. I get negative 4. Right there.